Levels no. Good morning, ma. So first day group elements, general characteristics completed. The next one, last class. Compounds of first day group elements. Useful compounds. Sodium hydroxide, sodium carbonate, sodium bicarbonate, and sodium chloride. These are the useful compounds of first year. So first one is the sodium hydroxide. First compound is the sodium hydroxide. So sodium hydroxide is also called caustic soda. Caustic soda. Okay, caustic soda. Because of its causticizing nature. Causticizing nature means it can decompose the protein. It can decompose the protein. It is called causticizing nature. So due to causticizing nature, it is called caustic soda. It is called caustic soda. KOH is called caustic potash. Potassium hydroxide is called caustic potash. It is a sodium hydroxide. Caustic soda, because of its causticizing nature, it is called caustic soda. It is prepared by electrolysis of brine solution. So brine solution means sodium chloride aqueous solution. In nearly 10% of sodium chloride solution is called brine solution. So this brine solution means NaCl aqueous solution on electrolysis. Aqueous solution on electrolysis. Sodium hydroxide is obtained in this reaction. Chlorine gas liberated at anode and hydrogen gas liberated at cathode. So to electrolyze the NaCl, we use electrolytic cell. It is called Nelson cell. It is called Nelson cell. So this Nelson's, by using this Nelson cell method, we can prepare sodium hydroxide. Second one, chlorine. Chlorine is the important gas. So it is the important byproduct. Chlorine gas liberated anode. Hydrogen gas is also important gas. So what are the important byproducts? Here chlorine and hydrogen are important byproducts. So it is the electrolysis method is the most useful method. So it is called Nelson cell method. So in this method, porous steel tank used as electrolytic cell. Porous steel tank used as electrolytic cell. So inside it is coated with asbestos. Inside it is coated with asbestos. Inside it is coated with asbestos. So this steel tank directly acts as steel tank. So this steel tank directly acts as a cathode. It acts as a cathode. Okay. So brine solution means aqueous sodium chloride is taken in. It is the electrolyte. Aqueous NaCl, it is the electrolyte. So here graphite rod is arranged in it. Graphite rod. So this graphite rod acts as anode. Anode. The next one, this steel tank acts as cathode. Steel tank acts as cathode. Graphite rod acts as anode. So it is completely covered. It is the outlet to collect the chlorine gas. It is the outlet to collect the chlorine gas. So this entire steel tank is suspended in another iron tank. Okay, na? So it is the receiver. Sodium hydroxide is received outside the steel tank. Okay, so here chlorine gas is liberated at anode. So by electrolysis, aqueous solution of sodium chloride is ionized to Na plus and Cl minus ion. Cl minus ion is anion. So anion goes to anode. So the reaction takes place at anode is oxidation. So two chloride ions loses 2 electrons. It liberates chlorine gas. So the gas liberated at anode is chlorine gas. It is collected in cylinders. Okay. Next up, so Na plus ions are present in this aqueous solution. Aqueous means it contains water. So the reaction takes place at the cathode. Reaction takes place at the cathode. Water undergoes electrolysis, so it undergoes reduction. Reaction takes place at anode is oxidation. Reaction takes place at the cathode is a reduction. So it gains 2 electrons, it liberates hydrogen gas, and it can produce 2 OH minus ions. It can produce as 2 OH minus ions. So here Na plus ions are present. Na plus ions combined with OH minus ions coming from water. So it is converted to sodium hydroxide. Next, so hydrogen gas is liberated in cathode. It is also collected in cylinders. This sodium hydroxide is passed through this pores. It is collected in the receiver. It is a Nelson cell process. So the chlorine gas liberated anode, it is called oxidation. Hydrogen gas liberated in cathode, it is considered as reduction. So it is the electrolysis of aqueous solution of sodium chloride. It is also called Nelson cell method. So in this method, what are the byproducts? Chlorine and hydrogen. So industrially, sodium hydroxide is prepared by Nelson cell process. Next, industrially, chlorine gas is prepared by same Nelson cell process. So by Nelson cell process, we can prepare both sodium hydroxide and the chlorine. So it is the useful method. The next one is the second method, Kastner-Kellner method. Kastner-Kellner method. So in this Kastner-Kellner method, rectangular shape of iron tank used as electrolytic cell. Iron tank, it is the iron tank. So this iron tank is used as electrolytic cell. Okay. So it is divided into 3 compartments. It is divided into 3 compartments by using 2 metal plates. Okay, na? By arranging 2 metal plates, so it is divided into how many compartments? 3 compartments. So these 2 are considered as side compartments. It is considered as a middle compartment. Okay, na? Side compartments and a middle compartment. So bottom these metal plates do not touch with the bottom of the iron tank. They are arranged in grooves. And the bottom of the iron tank is covered with mercury. So bottom of the iron tank is covered with mercury. So this mercury acts as intermediate electron. It is covered with mercury. So in the side compartments, sodium chloride aqueous solution is taken in side compartments. Okay, na? So it is the sodium chloride aqueous solution. So what is the electrolyte in the side compartments? Aqueous sodium chloride. Next, middle compartment. So very dilute sodium hydroxide is taken in middle compartment. Very dilute sodium hydroxide is taken in middle compartment. Next, in the side compartments. So here graphite rods are arranged in side compartment. Graphite rod. So graphite rods are arranged in side compartments. So it is the graphite rod. So this graphite rod acts as anode. It acts as a anode. So it is the graphite acts as anode. Next one. Next two, it is anode. So in mercury in side compartments acts as a cathode. It is cathode. So mercury cathode. In the side compartments, mercury acts as cathode. Graphite rod acts as anode. Okay now. So anode is completed. Cathode, electrolyte. So in the side compartment, what is the electrolyte? What is anode and what is cathode? Electrolyte is aqueous solution of sodium chloride. What is anode? Graphite rod. What is cathode? Mercury acts as cathode. In the middle compartment, what is the electrolyte? Dilute sodium hydroxide is the electrolyte. What is anode? What is cathode? So here iron rods, series of iron rods are arranged in arranged in middle compartment. So these iron rods means iron acts as cathode. Next, in the middle compartments, this mercury acts as anode. Next, so these are iron rods, series of iron rods. So iron rod acts as a cathode. So in middle compartment, what is the electrolyte? Sodium hydroxide, very dilute sodium hydroxide solution. What is the anode? Mercury. What is cathode? Series of iron rods. Okay, na? So here reactions takes place in side compartment. Reactions takes place in middle compartment. So what is the electrolyte? Electrolyte is the aqueous sodium chloride. What is the electrolyte in middle compartment? So electrolyte is very dilute sodium hydroxide solution. Next one. What is the anode? What is the anode inside compartment? So graphite rod used as a or acts as a anode. In a middle compartment, what is the anode? Mercury acts as an anode. So what is the cathode inside compartment? What is the cathode in middle side compartment? So mercury acts as a cathode. Next one, what is the cathode? Iron rods. Okay, na? So iron rods acts as a cathode. It is a electrolyte, anode, cathode are important. So mercury, bottom of the iron tank is completely covered with mercury. It acts as intermediate electrode. Means in the side compartment, mercury acts as cathode. In middle compartment, so in middle compartment, so cathode is iron. So in middle compartment, mercury acts as a anode. But inside compartment, it acts as a cathode. Okay, na? So it is anode, cathode. And here in the bottom of the iron tank, a rotary wheel is arranged. Rotary wheel is arranged bottom of the iron tank. So to move the iron tank, here a wheel is arranged bottom of the iron tank. So it is the construction of iron tank. Okay, it is the construction of iron tank. It is completely closed. These are outlets to collect the gases. So it is the construction of Kastner-Kellner cell. So these 3 points are important. So in this process, mercury acts as intermediate electrode. In the side compartment, it acts as cathode. In the middle compartment, it acts as anode. So electrolyte, anode, cathode, these are important. The next one, the reactions takes place in the side compartment. The reactions takes place in side compartment. So in the side compartment, reactions takes place. Aqueous sodium chloride, NaCl aqueous. It is ionized to Na plus and Cl minus ions. 2 Cl minus ions. Okay. So Cl minus ion is anion. Anion goes to anode because of anode is the positive electrode. So at anode, 2 chloride ions loses 2 electrons, means de-electronation. Chlorine gas is liberated. It is called oxidation, de-electronation. So in electrolysis process, the reaction takes place at anode is oxidation. So chlorine gas is liberated from side compartments. The gas is liberated from side compartments. Chlorine gas is liberated from side compartments. The next one, what is the reaction takes place at cathode? Cathode. So cathode is the negative electrode. Here mercury acts as a cathode. So this is mercury at cathode. Reduction reaction takes place at cathode. So 2 Na plus ions gains 2 electrons. Okay, na? Gains 2 electrons. So it forms sodium atom. Sodium combined with mercury. It forms a sodium amalgam. Na2Hg. Sodium amalgam is formed. So at the anode, it is the anode reaction and the chlorine gas is liberated. It is the cathode reaction. So here sodium amalgam is formed. So here sodium amalgam is formed inside the compartments. Next one. So this electrolytic cell is moved with the help of this rotary wheel arranged at the bottom of the iron tank. So all the way, this sodium amalgam formed in the side compartments is reaches to middle compartment. It is reaches to middle compartment. So what are the reactions takes place in middle compartment? Middle compartment. So in the middle compartment, mercury is anode. Mercury is a anode. So the reaction takes place at the anode. Anode is the mercury. So reaction takes place at the anode is oxidation. Oxidation means de-electronation. De-electronation. So here sodium amalgam is formed. It is reaches to middle compartment. Here mercury acts as anode. So at the anode, this Na2Hg is converted to, so it loses 2 electrons, de-electronation, that is oxidation. So it gives 2 Na plus ions and mercury. Sodium amalgam is converted to mercury. Na plus ions are formed. So these are Na plus ions. These are Na plus ions. The next one, the reaction takes place at the cathode. Reaction takes place at the cathode. Cathode means iron rods acts as cathode. So the reaction takes place at the cathode is a reduction. Reduction means gaining of electrons. So 2 moles of water, okay, no? 2 moles of water gains electrons. So it liberates hydrogen gas. It liberates hydrogen gas, and it can produce as OH minus ions. So from middle compartment, the gas which is liberated from middle compartment is hydrogen gas. So hydrogen gas is liberated from middle compartment. Chlorine gas is liberated from side compartments. So here OH minus ions are formed. OH minus ions are formed. These OH minus ions combined with Na plus ions formed at anode. So Na plus ions combined with NaOH minus ions of water. So sodium hydroxide is formed. NaOH. So in the middle compartment, we take very dilute sodium hydroxide. So in the formation of sodium hydroxide, the concentration of sodium hydroxide in the middle compartment increases. It reaches to nearly 20%. So it is removed from the sodium hydroxide. The percentage of sodium hydroxide reaches to nearly 20%, like in fermentation. So here 20% of sodium hydroxide is removed from this electrolytic cell, and on crystallization, so sodium hydroxide is obtained. So it is a Kastner-Kellner method. So it is a very important. So what is the electrolyte anode and cathode in the side compartment? What is the electrolyte anode and cathode in middle compartment? Next one, what is the anode reaction and the cathode reaction in side compartment? And what is the reaction takes place at the anode and the middle compartment? Reaction at the anode and the cathode. In electrolysis, reaction takes place at anode is oxidation, that is de-electronation. Reaction takes place at the cathode is a reduction. Reduction means electronation. So it is the Kastner-Kellner method. So commercially sodium hydroxide is prepared by electrolysis of sodium chloride. So electrolysis takes place by 2 methods. First one is the Nelson cell method. It is the most useful method. The next one is the Kastner-Kellner method. Kastner-Kellner method. So these are the methods of preparations of sodium hydroxide. Okay, ma? So electrolyte anode cathode reaction and cathode reaction inside compartments and middle compartment is important. The gas liberated from side compartment is chlorine gas. The gas liberated from middle compartment is a hydrogen gas. So hydrogen gas liberated, the gas is liberated. Next to electrolyte, anode, cathode, and anode reaction, cathode reaction. These are important reactions. Okay, the next properties of sodium hydroxide. What are the properties of sodium hydroxide? So sodium hydroxide is white crystalline substance. Next to it is dissolved in water. Dissolution of sodium hydroxide. It is more soluble in water. So it is in a solid state. White crystalline solid sodium hydroxide in a solid state. It is more soluble in water. More soluble in water. And the dissolution of sodium hydroxide in water is exothermic reaction. Dissolution of sodium hydroxide. Sodium hydroxide aqueous solution is formed. It is exothermic reaction, means heat is evolved. It is exothermic reaction. Exothermic reaction. So in this process, so it is exothermic reaction, and the nature of aqueous solution is basic in nature. Nature of aqueous solution. Nature of aqueous solution is basic. pH value is greater than 7. It is considered as first group oxides and hydroxides are strong bases. So what is the nature of aqueous solution of sodium hydroxide? Basic in nature. It is the monoacidic base. Monoacidic base. Monoacidic base means it can produce only one OH minus ion. So molecular weight is equal to equivalent weight and molarity is equal to normality. Next one, this sodium hydroxide has a hygroscopic in nature. So hygroscopic nature means it can absorb moisture from atmospheric air. It absorbs moisture in atmospheric air. So it can form hydrated salt. So it forms NaOH, NH2O, where N value is 1, 2, 3 up to 7. It can coordinate 7 water molecules. It is hygroscopic and it is deliquescent, like lithium chloride and magnesium chloride. It is a deliquescent, means it absorbs atmosphere moisture from atmospheric air and it is a soluble, means it is converted into liquid. So it is a hygroscopic and it is considered as a hygroscopic and it is a deliquescent. So it is converted to liquid. It is the sodium hydroxide. So it is exothermic, monobasic, more soluble in water. It is a strong base, monoacidic base. So molarity and normality both are same. So molarity is equal to normality. It can absorb some moisture from atmospheric air. It can form hydrated. NaOH, NH2O, N value up to 7, 1, 2, so on up to 7. Next, it is also considered as a deliquescent, means it absorbs moisture and it converted to liquid. Okay, it is a properties. And the sodium hydroxide has a high melting point, so it melts at nearly 850 degrees Kelvin. 850 Kelvin temperature. Next one, what are the properties of sodium hydroxide? Properties of sodium hydroxide. First one, action with acids. Sodium hydroxide is the strong base. Okay, so it reacts with acids. Neutralization takes place. So salt and water are formed. So sodium hydroxide, NaOH, neutralizes acids. Example with HCl. Sodium chloride, NaCl is formed and 1 mole of water. Because of it is a monoacidic base, it is a monobasic acid. When it reacts with the sulfuric acid, 2 moles of sodium hydroxide reacts with the sulfuric acid, it forms a sodium sulfate and 2 moles of water. When it reacts with the phosphoric acid, H3PO4, so 3 moles of NaOH. Here 3 moles of NaOH reacts with 1 mole of phosphoric acid. Here 2 moles of NaOH reacts with 1 mole of sulfuric acid. So here the salt formed is Na3PO4 because of this the tri-basic acid. So it forms a salt. Neutralization. Okay, these are all considered as neutralization reactions. So sodium hydroxide can also react with glass and porcelain. So hence it is not stored in glass because or porcelain because of it can combine with glass. Glass is a mixture of silicates. Glass is a mixture of silicates. So sodium hydroxide reacts with silicates in glass. It can form silicates. It can form silicates. It can form silicates. Hence sodium hydroxide cannot be stored in glass, beakers, or porcelain containers because of it forms silicates. So it is the action with acids, neutralization takes place, salt and water are formed. The next one, action with metals, action with non-metals, action with metals and action with non-metals. So action with the second one with metals, with metals. So with zinc metal or aluminum metal or tin metal or with beryllium metal, it liberates hydrogen gas. It liberates hydrogen gas. So sodium hydroxide reacts with either zinc metal or it reacts with tin metal or reacts with beryllium or reacts with aluminum. It liberates hydrogen gas. 1 mole of hydrogen gas. It liberates 1 mole of hydrogen gas. With tin, it liberates 1 mole of hydrogen gas. 1 mole of hydrogen gas. With beryllium, it liberates 1 mole of hydrogen gas. Whereas with aluminum, it liberates 3 moles of hydrogen gas. It liberates 3 moles of hydrogen gas. Here with the zinc, it forms sodium zincate. Na2ZnO2 sodium zincate. With the tin, sodium stannite is formed NaSN, Na2SnO2. Sodium stannite is formed. With the beryllium, it forms berylites is formed. Be Na2 BeO3 is formed. Na2 BeO3 is formed. The next one is here sodium metaluminate NaAlO2 is formed. Sodium metaluminate. Sodium zincate. Sodium stannite. Next one, sodium berylite. Next one, sodium metaluminate. Here 1 mole of hydrogen, 1 mole of hydrogen, 1 mole of hydrogen. But whereas with aluminum it liberates how many moles of hydrogen? 3 moles of hydrogen gas. So ratio of number of moles of hydrogen gas liberated when sodium hydroxide reacts with zinc and aluminum. So with zinc, it liberates 1 mole. With aluminum, it liberates 3 mole. So what is the ratio of hydrogen gas liberated? 1:3 ratio. So with the metals, it liberates hydrogen gas. With the zinc, sodium zincate is formed. With the tin, sodium stannate is formed. Sodium stannite is formed. With the beryllium, berylite, sodium berylite is formed. Aluminum, sodium metaluminate is formed in aqueous state. Okay, so here in all the reactions, 1 mole of hydrogen gas is liberated except with aluminum. With aluminum, it liberates how many moles of hydrogen gas? 3 moles of hydrogen gas. The next one, with non-metals. Third one, with non-metals. With non-metals. With non-metals. So with non-metals means first one with fluorine, second one with chlorine, third one with phosphorus, fourth one with silicon. These are the non-metals. Okay, now? So with the fluorine, with the chlorine, with the phosphorus, and with the silicon. So with the non-metals is very important. Here the products and the gases liberated depends on temperature and concentration of sodium hydroxide. Temperature and concentration of sodium hydroxide. So when fluorine reacts with cold and dilute sodium hydroxide, cold and dilute sodium hydroxide, here the gas liberated is OF2. OF2 gas is liberated. OF2. Sodium fluoride is formed NaF. Sodium fluoride is formed NaF. OF2. So OF2, oxygen difluoride gas is liberated. It is very important. Okay, now? So fluorine, OF2. Next sodium fluoride. Sodium fluoride. Sodium fluoride is formed. OF2 gas is liberated. The next one, number of oxygens. Total number of oxygens 2, hydrogens 2. So H2O. So here the gas, it is important. Fluorine gas reacts with or fluorine gas is passed through cold and dilute sodium hydroxide and gas liberated is OF2. Then same fluorine gas is passed through hot and concentrated sodium hydroxide. Hot and concentrated sodium hydroxide. The gas liberated is oxygen. It liberates oxygen gas. So it is important. With the dilute sodium hydroxide, it liberates OF2 gas. With a hot and concentrated sodium hydroxide, it liberates oxygen gas. Sodium chloride and water are the common byproduct. So these two are important. So when fluorine gas is passed through cold and dilute sodium hydroxide, the gas liberated is OF2. Next one, when fluorine gas is passed through hot and concentrated sulfuric acid, gas liberated is oxygen. Next, the second one is with chlorine. Here also say chlorine reacts with cold and dilute sodium hydroxide. Cold and dilute sodium hydroxide. It forms sodium chloride. Sodium hypochlorite NaOCl and water. Sodium chloride, it is called sodium hypochlorite. Sodium hypochlorite, Na plus 1, OCl minus 1. Okay now. So number of sodium atoms 2. So 1 mole of chlorine reacts with 2 moles of NaOH. It forms 1 mole of NaCl, 1 mole of NaOCl and 1. When second reaction, same chlorine reacts with our chlorine gas is passed through hot and concentrated sodium hydroxide solution. Hot and concentrated sodium hydroxide solution. Here sodium chloride is formed NaCl and sodium chlorate. Sodium chlorate formula NaClO3 and water. It is called sodium chlorate. Sodium chlorate. We know the potassium chlorate formula KClO3. So KClO3 on heating it gives 2 moles of KCl and 3 moles of oxygen. It is used in stoichiometric calculations. Okay. So when chlorine gas is passed through hot and concentrated sodium hydroxide, sodium chloride is the common product. Here NaOCl is formed. Here NaClO3 is formed. Here oxidation state of chlorine is +5. Here oxidation state of chlorine is +1. So these two are examples for disproportionation reactions. These two are examples of disproportionation. What is the disproportionation reaction? In a reaction, in a redox reaction, only one element undergoes both oxidation and reduction is called disproportionation reaction. Here oxidation state of chlorine is 0. In sodium chloride, oxidation state of chlorine is -1. 0 to -1 decreases. 0 to +1 increases. So only chlorine undergoes reduction and oxidation. So it is example for disproportionation reaction. Chlorine reacts with hot and sodium hydroxide. Is also disproportionation. Here oxidation of chlorine is 0. Here -1. Here +5. 0 to -1 decreases. 0 to +5 increases. So it is a disproportionation reaction. But not fluorine reacts with sodium hydroxide or potassium hydroxide is not disproportionation reaction. Chlorine undergoes the disproportionation. Bromine undergoes the disproportionation. Iodine undergoes the disproportionation, but not to fluorine. Because to undergo disproportionation, the element can exhibit minimum 3 oxidation states. Okay. Example here, take fluorine. In the molecular state, its oxidation state is 0. Reduction means it is converted into F-1. It is possible. Okay. It is decreasing. Reduction. Oxidation is not possible. Fluorine does not exhibit a positive oxidation state. Only 0 to -1 is possible. But 0 to +1 or +3 or +5 or +7 is not possible. So fluorine exhibits only 2 oxidation states. In a molecular state 0, in ionic state -1. So to undergo disproportionation reaction, the element exhibits a minimum how many oxidation states? 3 oxidation states. So fluorine does not undergo disproportionation reaction. But chlorine reacts with either sodium hydroxide or potassium hydroxide, or bromine reacts with alkali solution, or iodine reacts with alkali solution is example for disproportionation, but not chlorine. Is not, this reaction is not disproportionation because of only reduction is possible, oxidation is not possible. So it is a disproportionation reaction. The next property, next non-metal with phosphorus. So sodium hydroxide reacts with phosphorus is also sodium hydroxide reacts with phosphorus is also disproportionation reaction. Here the gas liberated is phosphine. Phosphine. Here the product formed is NaH2PO2. Sodium hypophosphite is formed. So number of phosphorus atoms are 4. So number of sodium is 3. So 3 NaO hai. 3 moles of NaOH reacts with 1 mole of phosphorus. It gives 1 mole of phosphine. It is in gaseous state. It is also example for disproportionation reaction. Here phosphorus molecule in a molecular state, its oxidation state is 0. In a pH 3, oxidation state of phosphorus is -3. So it is a reduction. Next, it forms NaH2PO2. Oxidation state of phosphorus in this reaction, NaH2PO2. Oxidation state of phosphorus in this reaction is +1. So 1 + 2, 3. This is -4. X -1 is equal to 0. Therefore, x is equal to +1. So 0 to +1. So it is considered as oxidation. So chlorine reacts with sodium hydroxide is disproportionation. Phosphorus reacts with sodium hydroxide is disproportionation, but not fluorine reacts with sodium hydroxide is not disproportionation reaction. When fluorine reacts with cold and dilute NaOH or KOH, the gas liberated is OF2. When fluorine reacts with hot and concentrated either NaOH or KOH, the gas liberated is oxygen. Here chlorine or bromine or iodine forms so halides and hypohalides. With hot and concentrated, it forms halide and halide. We take bromine, sodium bromate is formed. We take iodine, sodium iodide is formed. Next one, so chlorine reacts, chlorine or bromine or iodine or phosphorus reacts with sodium hydroxide is example for disproportionation reaction, but not with fluorine. So among the following, sodium reacts with the following elements is not a disproportionation reaction. Not a disproportionation reaction. First option is fluorine, second option is fluorine, third option is bromine, fourth option is iodine. Not a disproportionation with fluorine is not a disproportionation. Or fourth option with phosphorus. So with phosphorus is also disproportionation. With bromine, disproportionation. With chlorine, disproportionation. But with fluorine, it is not a disproportionation reaction. So why fluorine? Fluorine does not undergo disproportionation. To undergo disproportionation, any element can exhibit minimum how many oxidation states? 3 oxidation states. But fluorine, only 2 states are possible. 0 in molecular state, in ionic state, in compounds or in ionic state only -1 is possible. Hence, fluorine does not undergo disproportionation. But fluorine undergoes disproportionation, bromine undergoes disproportionation, iodine undergoes disproportionation, phosphorus undergoes disproportionation with sodium hydroxide. The next one with silicon. Sodium hydroxide reacts with silicon. Sodium silicate is formed. Sodium silicate. So Na2SiO3. It forms sodium silicate. So these are the action with acids, action with metals, action with non-metals, with fluorine, with chlorine, with phosphorus, and the last element is that is silicon. The next, what are the uses of sodium hydroxide? So sodium hydroxide is mainly used as a laboratory reagent. Okay, na? Mainly used as a laboratory reagent. It is used in the cleaning of glasswares and porcelain tiles. Next one, sodium hydroxide is used in petroleum industries, refineries. Sodium hydroxide is also used in cotton industries to mixerize the cotton. Mixerize the cotton. So important laboratory reagent. Next, it is used in pure cleaning of glasswares and crockeries. The next one, it is used in petroleum refineries. It is used in cotton industries. Cotton industries. The next, this sodium hydroxide is also used in the preparation of sodium chloride, sodium peroxide, etc. Many useful compounds are prepared from sodium hydroxide. So these are the uses of sodium hydroxide. So remaining compounds, sodium carbonate. So only method and no chemical properties. Sodium bicarbonate. So preparation of only one method and no chemical properties. Sodium chloride. So no preparation method, no chemical properties. It is mainly sodium chloride is obtained from seawater. The next one, biological importance of first year group elements. Okay. So in the next class, within first 10 to 15 minutes, we'll complete the carbonate, bicarbonate, sodium chloride, and biological importance of first year group, and then we will start the alkaline earth metals, that is second year group. Okay. Right. Thank you.